You ever stop and think about what actually makes your computer work? I mean, it's not just the screen and the keyboard, right? There's this hidden force, this silent manager that's doing all the heavy lifting. Well, today we're going to pull back the curtain on that unseen hero, the operating system.
I mean, just think about it for a second. You click on an icon, and poof, it just opens. It feels like magic, doesn't it? But behind that one simple click, there's this incredibly complex dance happening between software and hardware. So, the real question is, who's the choreographer? Yup, you guessed it. It's the operating system, or OS for short. You can think of it as the master conductor of an orchestra. It's literally the first program that wakes up when you boot up your computer, and it just works tirelessly in the background, making sure every other program plays its part perfectly. All right, so let's get into it. To really get a handle on the OS, we kind of need to figure out where it fits in the grand scheme of things, the layers of your machine. Okay, so this diagram really lays it all out. Down at the very bottom, you've got the physical hardware, the chips, the memory, all the metal and silicon. Then, way up at the top, that's us, the users, clicking away on our apps. And right there, smack in the middle, is the operating system. It's this crucial layer of system software that acts as the ultimate translator. It takes what we want to do and turns it into a language the hardware can actually understand and execute. So what does this master translator actually do all day? Well, it's a master juggler, really. It's constantly managing all these critical resources just to keep your computer from crashing. So let's take a look at two of its biggest, most important jobs. First on the list is memory management. And this one's huge. Just imagine your computer's memory, its RAM, is like a giant library with a ton of shelves. Every single program you run needs some shelf space for its books, right? For its data. The OS, it's the super meticulous librarian. It's deciding, okay, you get this shelf, you get that one, but only for a little while. And most importantly, it makes sure nobody is scribbling in anyone else's books. It keeps everything organized and separate. So let's break down what our librarian is actually doing. For starters, it's keeping track of every single memory location, just to know what's free and what's taken. Then it decides which programs get memory and for how long. It allocates that memory when a program says, hey, I need some space. And just as important, it takes that memory back. It deallocates it when the program is done. This constant cleanup is what prevents total system-wide chaos. All right, the second core job is a concept called resource abstraction. And honestly, this is a really, really powerful idea. Think about a light switch. You just flip it. On, off. You don't need to know anything about the electrical wiring in the walls, the circuit breakers, or the power grid miles away. The OS does the exact same thing for software. It completely hides all the messy, super complicated details of the hardware. So why is that such a big deal? Well, for one, it makes life way easier for developers. They can just focus on building cool apps, and they don't have to worry about the specific hardware it's going to run on. That also means their code is reusable. The same app can work on tons of different computers. It also protects the guts of the system from being messed with. And for you, the user, it creates that consistent, predictable experience you expect every time you turn it on. Now, you've got to understand, the sleek OS we use today didn't just pop into existence. Oh no, it evolved over decades, constantly adapting to new challenges. So let's hop in a time machine for a quick trip to see how our hero has changed over the years. Okay, so way back in the early days, you couldn't just sit down and use a computer. There was no direct interaction at all. Instead, a human operator would physically collect jobs, like a stack of punch cards for payroll, group them into a batch, and then feed that whole batch to a giant mainframe computer. And the computer would just chug through them one by one. Super inefficient by today's standards, but hey, it was a start. And then came the real game changer, multitasking. This right here is the foundation of pretty much every personal computer experience we have today. The OS got smart. It figured out how to juggle multiple programs at what seems like the same time. It switches between them so blindingly fast, we're talking tiny fractions of a second, that it creates this perfect illusion that your web browser, your music player, and your spreadsheet are all running at once. Time sharing basically took that multitasking idea and cranked it up a notch, applying it to multiple users. The idea was you could have one big, powerful computer and it could serve dozens of people simultaneously. How? By giving each person a tiny, tiny slice of its processing time, a little time slice or quantum. It would cycle through all the users so fast that every single person felt like they had that entire powerful machine all to themselves. And the evolution just kept going. We started developing really specialized systems. For instance, distributed operating systems, which can link a whole bunch of separate computers together so they act like one single seamless network. And then you have the really critical stuff, real-time operating systems. These are systems where a response has to happen within a super strict deadline. We're talking about things like air traffic control or robotic surgery, situations where any delay, any lag at all is just not an option. Okay, now we're going to get to the very heart of it all. We're going deep inside the OS, to its most protected, most powerful inner sanctum, the kernel. So to keep the whole system safe and stable, the OS has this brilliant split personality. It operates in two completely different modes. Think of it like a kingdom. You have user mode. That's where all the citizens live, your applications. They can go about their business, but their power is pretty restricted. Then you have kernel mode. This is the inner castle, the protected fortress. It's the privileged or master mode where the OS kernel itself lives. And from inside that castle, it has complete, unrestricted access to everything in the kingdom, all the hardware. The kernel, it really is the absolute core of the whole operation. It's the boss. It handles everything we've been talking about, the memory management, scheduling what runs when, and acting as that fundamental bridge between all your software and the physical hardware. You can think of it as the single most trusted piece of software on your entire computer, period. So you might be wondering, how does a normal, everyday app stuck in user mode get help from the all-powerful kernel? Well, it can't just barge in. It has to use a very formal, very secure process called a system call. Let's walk through it. Say your word processor needs to save a file. It is not allowed to touch the hard drive directly, so instead it makes a system call. It's basically knocking politely on the castle door. The CPU then safely switches from user mode into kernel mode. The kernel does the heavy lifting, it saves the file with its full privileges. And then once it's done, the CPU switches right back to user mode and hands control back to your app. It's just a beautiful, secure, and incredibly efficient system. All right, we've just covered some pretty deep concepts, from memory management all the way to kernel mode. So let's bring this all back down to earth and talk about the devices we're all using every single day. The truth is, you are literally surrounded by these unseen heroes. I mean, whether you're on a PC running Windows, a Mac with Mac OS, a server humming along with Linux, or even a Chromebook with Chrome OS, all of these core principles are at work right now. And hey, don't forget about the incredibly powerful and sophisticated operating system running on that phone that's probably in your pocket as we speak. At the end of the day, it really all boils down to this one simple, powerful idea. The OS is that essential communication bridge. It sits between you, the user, and the computer's hardware. It's the magic piece of software that connects our ideas to the physical world of silicon and electricity. And that kind of brings us to a final thought to leave you with. We've seen how the OS has evolved, right? From those clunky old batch processors to the multitasking powerhouses we have today. But what's next? As we move into this wild new era of AI, the Internet of Things, and just everything being connected all the time, what new challenges is our unseen hero going to have to conquer? What will the OS of the future even look like? It's definitely something to think about.